Go-101. I'm very excited. I hope you all are. And today's session is going to be led by Francis Annin. Francis is the face of Annin Software. He's a great mind and I admire him a lot. He has been working with Go as one of his primary languages for the past 6 years. So he's bringing a wealth of experience today. And the topic is going to be on one of my favorite Go topics, handling of errors, error handling in Go. So I hope we follow and then we ask questions if we have any. Enjoy. The floor is yours, Francis.
Okay. Thank you so much, Dennis. Yeah, thank you all. Once again, you're all welcome to today's session. I was expecting that we would have a lot more numbers, but I mean, it's fine. We can just go through it. So in the next 30 minutes, we'll be looking at error handling, and I know a lot of you guys here know like what errors are and all of that, but um, we'll just take a look at how they are handled in Go and some few other stuff. So just share my screen and we'll take it from here. Yeah. Okay. Um, can you see my screen? It's, it's not.
Yeah.
All right. Okay. So my name is Francis Annin, as Dennis rightfully mentioned. Yeah. So I hope today you guys enjoy it. But anyway, it will not be lengthy. It will not be much. Just something small. So errors. What are errors? Errors are basically in some languages they are known as exceptions, right? So it's something that tells you about you how well your program is doing, one way or the other, or whether your program has gone wrong or something of that sort, right? So it tells you there's something not going right. Okay, so that's basically an error. But in Go, in a technical term, an error is a type. It's a type that's or any type that satisfies a certain interface, right? Um, I don't know if you guys know of an interface or anything, but I will just look at it. So today, just let's go through this very quickly. We'll just be handling these things here, trying to understand errors, just see a comparison with error handling in Go and some other language. Error as an interface, um, error functions that we have in the error package, then defining your own custom error types, and then in the end maybe we'll just look at login and some patterns that will be useful for us. Right. So errors are basically a good thing. Right. You shouldn't see errors as something that stresses you out. Though we all have like one way or the other. If you've programmed for some time, you know that anytime you have an error, it's just like come with a lot of stress and you feel uneasy. But it's not supposed to be the way. Anytime you have an error, the more errors you solve, the better your program becomes, right? So errors are basically your friend. They are actually that friend that directs you in the right path. So I think we should henceforth change our mindset about how we see errors. Shouldn't see them as a struggling friend or something, but rather a friend that is pointing us in the direction for us to build strong and robust programs. Yeah. So I actually got this from last week's presentation. So when Ernest was presenting in the chats in the comment section, I think we were talking about JavaScript and some other languages and how their errors are handled. And I got this. I felt like it was cool. So this statement here is basically saying that handling errors in Go, which most of the time, 99% of the time, is done by this statement, is greater than in JavaScript that uses try or catch block, right? Or maybe in Python that is like try except, or any other language that does that block based caption of exceptions and errors. Yeah. So let's look at how errors are mostly like handled in JavaScript. As I said, try catch block. So you can have your statement here, and this try here basically tests or it somehow checks to see if an error will occur. So here we are dividing by zero, and division by zero error is something that we are aware of. You can't divide a row number by zero; it's not possible. It's something that mathematically not possible. So then you put that sort of statement that has a potential to cause error in a try block, and you are hoping and praying that um, you catch that error and you log it out some way somehow. Um, well, that is one way of handling stuff, but then Go presents a very unique way of attempting or trying to handle your errors. Right. So those with JavaScript background or JavaScript lovers, I hope that at the end of the presentation, um, you guys will actually change your mind and maybe redesign how this whole thing here. Um, I know it'll be difficult, but like just really think about how you handle errors in your program. All right. So we'll just be diving into the hands-on very soon. Okay. So the same example here shown in JavaScript in Go. Um, Errors are values. That's one thing you have to know. Um, they just like the way you return a value from a function or from a process. Yeah, basically from a function. Errors are also returned in that way, and we would. This is a sample program of it, but we would try and maybe come back to this. But I want to explain what this are before. So errors are values. Let me just share my ID quickly. Oops, sorry. Just a second. I have this um this window. Yeah. Just a second, please. Okay, so let's clear our yeah, let's clear our our ID, our editor. Okay, so let's try and look at the example I shared about with the division. So let's say you have two numbers and you want to divide. Okay, write a division. Um, sorry, my keyboard. So you have a divide function this way, and it takes, let's say, two floating point numbers or something, right? So let's say float 64, and the other one is float as well. Um, these numbers could be zero, right? Now, what we yeah, they could be 0, 0.0. What we don't want is b to be 0. Anytime b is 0, the denominator is 0, the program will break. So we can basically say that if b is equal to like 0 um, or something, then we should actually return an error. Then this is the interesting part. You can just actually like say use the error function. Sorry. So use the error function called new to define a new error. Or you can use we'll talk about it later on. So you can define a new error message like this and return it this way here. Just so functions in Go expect a return type. So here you return, let's say, can't divide by 0, right? Right. But if it is not, then what you want to do is you want to be able to actually perform the division. So here you can see maybe so um, you can perform the results this way, and a divided by b. Mind you, the reason why we will not be able to return this object is because for now we are only returning the error. Okay, so you have to return, oops, sorry, you'd have to return the value as part of it. So this is it. So you can see maybe this will be the, the return state, the return value you'll be expecting as well. So here you have return the results and nil. So in this case, basically we can just say we would want to return 0, um, as well, just to indicate that, oh, just 0.0, but we can go a step further, and make it nullable, or make it accept null as well. But let's just go with this one. So here in your main function, you can just call divide this way. Then you pass in two numbers. So let's test the 10 and 0 this way. Now we know 10 and 0 won't necessarily work. Um, we expect to return values, a value, the result, and an error. So we can call this result error this way. Then we check it out. So if error is not empty, if like there is an error actually present, let's maybe just log out the error, a fatal log the error. But if not, let's print out the results this way. So this is just like a simple very much simple program, or like how to define an error in Go. And you can use this new function in the error package. Actually, this is a package. Error is a package, and new is a standalone function in there, which returns a string that implements the error type. It could be a bit confusing, but I'll show you guys soon. Okay, so on running this program, or once we're able to run this program, compile, blah blah blah. Okay, so we see that we get our error logged into the standard error, saying that cannot divide by 0, right? But once we change this to, let's say, another integer or something, then let's run again. So then we see the results. So we go, one thing is that errors are handled by each operation. When I say operation, I mean each function block, you handle the error gracefully and return it. So imagine you have a lot of functions that you're interacting with. Each time you would be handling its errors. If error is not equal to nil, do something, handle it, instead of the JavaScript approach, where it's like you have all, like, a whole bunch of code under one block, and the code is praying or hoping that nothing happens. But if there is an error, then you just tries and catches and logs it into the standard output. So this is one very interesting thing about Go that I want to talk about. That it takes errors on a different level of management. You handle it right from the function, and or whatever operation that you're doing, and it's a value as well, right? It's a value. This is a value. It can be compared. It's a value of type string. That's what an error is. It's a value of type string. Right. Okay. So we'll move on to the next thing. Um, so yeah, errors are also error is an interface, and an interface is an abstract class. I don't know if you guys have experience with like Java or some other C sharp. Yeah, I think if you've done C sharp before, or that, you'd see abstract classes. Though in Go we don't have abstract classes, no. We don't even have classes in the first place. So an error is more of like an abstract class, unlike a concrete class, where um, it says that, an interface, I'm sorry, it says that for all set of types that satisfy a certain method, they actually satisfy an interface. And what it means is that interface can be a type of that class. So I'll not go into an interface, but let me show you what I mean. So in this case you can have some, and this is how the error looks like. So an error has this, sorry, interface. Because I'm recording, my system is quite slow. But yeah, so this is basically an interface, for which this is an interface saying that all types that you define, or let's say class, right, or an object that you define, once the object has a method named error like this, and it returns a string, then it actually implements this error interface. So you can one way or the other, um, it, you can one way or the other use this as a type of that um, type. I don't know how to. So for example, let me put it this way: if let's say you define a type person, right? This is a type. Think of it as a class. Now on this type person, you have a method. Let's see. This is the receiver. This is second. This is a receiver, and this method here implements this and returns a string this way. Oops. Yeah, and it returns a string this way. Then this type person satisfies this interface of error because it has this error method, this, and it returns this. The signatures are the same, and it returns the string. Right. So here you can just say return, let's say FMT print line, then maybe you put in the name here or something like that, and yeah, you have sorry, let me not print this as print f. This would print can that you can create your own custom error type out of it, and we'll be looking at it very shortly. So that's this an interface, and yeah, that's what I wanted to talk about. So an error has this method. Any type that satisfies this also has this method implemented. It satisfies an error, and you see it returns a string. So this string means that all errors mostly in Go are of string type. When you return them, you decide to say that, oh, I want to break the flow. Let's say here we used a log fatal. Fatal is like it implements an OS exit. Let's see. So when you call this, it exits the program before we even get here. Yeah. Or you can just print them out, or you can panic, or you can do anything that you want. Unlike other programs where once there's an error in the stack, it automatically um, exits the the function exits and everything crashes. This one, the error actually is of a type string, and you decide to do what with like you want to do it. Some people can just log them out. Some people can print them silently and still continue with their flow and what's what. Um, so that's error for you. So let's go to the methods, the functions, the standalone functions we have in the error package. Right. So in the error package, this is the error package. I think we use, this is the error package. You can see it in your Go SDK. There's an error package. Look for it here. Errors. And this is the package. The name is errors. This is it. The name is errors, and these are standalone functions. So this new function actually takes in a type string, an object of string type, then it returns it to this type, which implements this. So this actually implements the error method. This one, you see this error method here, and it just returns it out. So it's just strings passing through the pipelines, just strings. Yeah, and we have another way to, aside the errors on new, for which you can create a new error or create a new error type. There's another how do I even call it? There's another way to create an error, which is like you use the format package, and it has an error format function. So this also, you can format your errors, or like OBS Studio is dealing with me very badly. Okay, so it returns an error. So here you can see that it returns an error, and it creates that error out of it. So the error is actually wrapped in this, and so you can see some nice error, some just anything you want. Nice error here. Yeah, this is it. So you have the error type created, and when you look at it, it's of type error, right? So these are the two ways you can gently create errors and return them. and they are all of type string. Beneath an error is of type string. It's just a string telling you something. You decide to act on the string, or do whatever you want to do with it. Yeah. So this is one thing that I wanted to talk about as well. It leads me to just log this out. Okay, so we'll move on to the next thing. Um, the next thing is, yeah, so you can use the FMT. This is what we talked about. Um, so I think this will be like the last major thing we'll talk about. Then yeah, that will be the end of my presentation. Okay, so with custom errors, as we said, again, it will still have to, it boils down to strings, but you are just doing some skirmishes with like creating your own types and what's not. So let's say we have this, we are building a program where we want to just write very niche error types for whatever thing we want. So let's take what will be a good example. Let's say we are building a program for a school, right? And we are just checking age or something, right? So invalid age error, right? So we can just create a new type and call it invalid age error, right? Then we create a struct for it. Then we say that, okay, the age, we pass in the age. So an age could be an int 64, an int any one you want. Then this type here, before we can implement this as an error, it actually has to implement this. Before we can call it as an error type, it has to implement this method as we saw here. All errors actually implement this. I'll just take this off for now. Yeah, then we can just, you just return something. You can always return something like this, or we can like perform a check, like do some check here. Then we return an error, do a check here. So because of time, I mean, I know you guys know how to do this thing, so because of time, I'll not do the check. Then actually send a message. So you can also add an error message as well as part of your type. So, and this will be a string, and you say that here you want the message to display. So this is how you create an error. Basically, this is how you create a custom error. So in your main function, you can come here and say that, like, okay, now let me just create a constructor for it. Please, if you are confused and you are confused about what the interfaces and the types and all of that, in our subsequent sessions we would handle them, so just don't worry. This topic should have been treated maybe later on, but that's fine. So yeah, and can create age error message this way, right? So here you can create a new error. You can create a new error. So let's say invalid, just like any normal function error, and then you specify its, oh gosh, new invalid error age. Then you specify your, yeah, you specify the message that you want to pass. Say maybe students age is invalid. Yeah, and this will return invalid age error, this type, which is actually an error. And anytime you call this, let's say, invalid the error method, it would print out the error that you wanted, right? So this one here is actually returning a string, just as we talked about. So you can log them um, using prints this the print new line. So this way, yeah. Then you get a string version of the error, and you can treat it as a value, as we talked about here, like handling errors and all of that. Yeah. So this is basically like trying to define your own custom error types, but in a type form. It just has to satisfy this error here, and it can be it's an error. Sorry, it's not an error. Once you satisfy this method, it's not an error. That's all that you need in Go for custom error types. Yeah. Okay. So we can go on to this basically like the example valid the student age. Yeah. So we'll just talk about logging in. Yeah, I'll bring my presentation to a close. So this here, the log package is more like you guys know of like logging, like just writing to the standard output, the standard stream. And in this case, when you have an error, you can pass that error message in any of these here. And of course, they are different. There are different functions and they act differently. But what they do is they log them out into the standard output. So like panic, for example, it will break the program and log it out in, as we saw earlier on when we ran the program with zero. You have it in standard output, and that is what's in languages like JavaScript and Python. You might think of it as like a stack trace, like you see track trace error something something, then it has this whole log of like trying to point you to where in your program like the error is occurring. Yeah, but for this it just logs the error out and just say, hey, this is this error that's happening because you decided to break your program. For example, if you are building like let's say a web service that is listening on a certain other service and you don't want to break your program, languages like um, Python and JavaScript, if you leave them to their default way of handling errors, it will break it for you. But with this, you can say, oh, I still want to see the error, but I don't want to panic or break it, right? So I would rather log it gently, like maybe just log it like a print, and then maybe write it to a text file for which I'll be checking like as time goes on. But my program should still run, right? So it gives you all sort of like tools and methods for you to like treat your program the way you want it to happen, right? This mode of I feel like Go brings like this new dynamic way of trying to handle errors, and in as much as it can be a bit new, I think we have to embrace it and to think about new ways for which we can build our programs and structure our programs around this. So this is the last thing I'll talk about. This is like best practices of handling error, and it's a sum of all that I've said. Basically, you can create custom error types, but it's not so important because then, in the end, when you look at it, they are all returning a string, right? So instead of going through this, trying to create your own error types, in the end, it still returns a string. So you can just go ahead and use this error.new function and create your string directly. Write your string directly in it, and that's all. Yeah. So you don't have to abuse the custom types, or you have a lot of scattered programs, like scattered objects um, in your program, unless you wish to arrange it nicely. Then functions that fail should also return an error, right? So if you are building any program, try and minimize the area of possible error that you can have. What I mean is, don't have a function that is like one function and it has like 300 lines of code and like that's obviously not something that you'd want to do. Okay, just simple functions, then you handle the error, then you move on to the next thing, pass the object into a new function, then that's it. Also, I think maybe this will be the time to talk about it. So with this, I think this is the end of my presentation. Yeah, just on time. If you have any